so excited to share this discussion with you all in the main room today because whether we work directly with batteries or not, their safety issues are all around us. Maybe you turned on an old laptop and noticed the pouch cells became what is known on Reddit as a spicy pillow. Maybe you've driven back from the Bay Area from Monterey and saw the Moss Landing incident on the side of the road. Maybe you work at a battery company and you're trying to put forward that your battery is safe. This is a huge topic that deserves transparency so that we can improve safety in our communities. And we have a great group of panelists who are all passionate about this topic and making the key findings of what we work on in the safety space more accessible to our industry so we can be better. With that, I'll introduce our panelists. First, we have Ben Wrightsman. Ben Wrightsman is a battery industry veteran with over 30 years of experience spanning lead acid, nickel metal hydride, and lithium ion technologies, including early work on the GM EV1. He led training efforts at the Battery Innovation Center, or BIC, and advocates for improved data transparency, application-specific validation, and prioritizing safety ahead of performance metrics. Next, we have Mike Nicholas. Mike Nicholas is a retired fire captain and assistant fire marshal with over 2 decades of experience and direct involvement in developing code and compliance standards for large-scale BESS installations. He helped establish the largest single battery energy storage project at 3.2 gigawatt hours and continues to advocate for rigorous testing, containment strategies, and long-term operational oversight. Next, we have Brian Sorin. Brian Sorin is the founder of Soteria Battery Innovation Group, which develops safety-enhancing technologies and leads a cross-industry consortium focused on improving battery safety. With a background in intellectual property and deep commitment to industry-wide collaboration, he promotes the integration of low-cost safety solutions and challenges conventional testing norms. And last but not least, we have Landis Knorr. Landis Knorr is an underwriter at GCube Insurance, specializing in utility-scale battery energy storage systems within renewable energy infrastructure. With a background in property and liability coverage, he brings a risk-based perspective shaped by real-world project losses, emphasizing site context, supply chain, and practical safety standards. So, speaking of safety standards, let's get into it. My first question is for Ben. Where are we at in terms of battery safety standards, and where are we falling short?
Yeah, great question. And by the way, I just want to say thanks to the other panelists. Glad to see some folks I know. Brian, glad to see him online as well, and great to meet Landis and Mike. Yeah, to answer your question, Laura, is they're actually finally coming better up to speed. I would say over the course of my term, even through a couple of years ago, the standards were really lagging, and frankly, that's just because of how long it takes to get those together to look at what's happening, plus the speed of emerging technology globally. And as you look at new technologies, that's still a challenge. And frankly, that's probably will stay an ongoing challenge, is how to standards that are usually reacting to artifacts versus out on the innovation curve. How do they get at least real time or near real time? And then what are they going to be able to do to get ahead of some of those? And there's some agencies that are doing much better at that. But overall, they're better than where they were, but we still have several that are lagging from an overall safety perspective. Most of those apply down to the general consumer awareness level. That's still probably the biggest gap, if there's any.
Thanks so much. Yeah, I totally agree with the work that I do at Exponent. There's, standards are not usually a one-size-fits-all solution. And yeah, we need to expand on them a lot. My next question, also kind of talking about standards, but with a little bit of a different viewpoint. This next question is for Landis. You had mentioned that during your underwriting process, you're developing your own types of standards to apply to that process. So where are you filling gaps in your work?
Yeah, thanks for having me here. I focus on utility scale BESS in the US and Canada. And as part of Tokyo Morin, we work on a worldwide basis, working on projects throughout Asia, Europe, South America. So our focus from a grid perspective, we're looking at primarily containerized BESS in outdoor places. And for us, the biggest challenge that we had was spacing. we know about UL 9540A, and I think our industry, property and casualty, feels that UL 9540A is a good start, but we weren't really sure what to do with it, right? We had some skepticism about it. Our concern from an insurance company perspective is that you'll see a thermal event in a container and it's going to quickly propagate through a lot of different containers. And we just didn't know how fast and quickly that propagation would occur. And that's the difference between a $1 million loss and a $200 million loss. And that's a lot in the world. So we had to kind of make up our own spacing guidelines. We generally were working with kind of an 8-foot perimeter around containers. And that's a bit of a rudimentary scale, but that basically says that if there's any equipment within 8 feet, it's going to get damaged and it's going to propagate from there. So we're looking at PDF files of site layouts and kind of drawing lines around it to see where propagation is going to occur. So we were really at that stage. We're really excited for new standards like the CSA C825. I think that is going to answer a lot of questions for us. That is the sort of thing where we're all used to saying UL 9540A. You can say it all the time. A lot of people in the insurance industry right now aren't familiar with the CSA standards that are coming out. And I think by the end of this year, it's going to be on the tip of the tongue for 100, 200 people within our space looking at this, and it's going to be in demand across the different manufacturers and technologies and projects that are being put in throughout the world.
Yeah.
So something that's really important to us.
Can you define really quick for the audience, like what the different standards are, the UL 9540A and this new CSA? What are they really titled and what do they cover, or what will they cover?
Yeah, so the big key is that the CSA is large scale fire testing. So large scale fire testing in the CSA, it is basically putting together 4 containers at different distances from one another and lighting one on fire and seeing if that propagates to the ones that are nearby. So one container is, I believe it's 15 centimeters. The other one's about 1.5 meters. The other one, I think, is 2.5 or 3.5 meters away. And they're looking to see whether or not the fire propagates. And it's really just 10 or tens of hours of video of a fire in one container and whether or not it jumps to the others. We're seeing manufacturers that are they're basically touting what their results and kind of putting videos out and trying to one up one another. I think Hithia maybe the other day put out a video where they can actually do it with the doors open and not allow any propagation. So from an insurance perspective, that's something that we've wanted for the past few years and haven't been getting. I suppose best manufacturers found better use of millions of dollars of equipment than setting it on fire. But for our benefit, now that they've gotten to that point, we're kind of thrilled, and it's going to mean a world of difference in terms of our confidence, and that's going to translate into insurance rates for the owners of these projects.
Very interesting. Yeah, I think those of us who work on things at the cell level and kind of pack level, we know about propagation testing at this level, but then when you have actual modules from BSS systems, this can probably be a very challenging test to run, I can assume. My next question is for Mike. So Mike, you have a lot of experience in applying it in developing actual fire code for these very large BESS projects, which we're currently discussing. Can you tell us about that and what you wish the battery cell and pack focus sectors of industry would do or understand better?
Sure. Yeah. So my former jurisdiction, Kern County Fire Department, had the unenviable task of trying to swallow the elephant whole and permit a 3.2 gigawatt hour project in multiple phases using a half a dozen different technologies. And so tying back into what Landis is talking about, NFP 855 2026 edition has added language in the annex about large-scale fire testing. CSA did not have their testing parameters quite finalized by the time the technical committee was voting on putting something like that into the code. So when we're looking at large-scale fire testing, that is the ultimate litmus test in making a determination about siting and distances between enclosures, because that is the main thrust of that particular test. We want to see a fully populated enclosure externally forced into a thermal runaway event with adjacent enclosures placed at a distance that you would see them on site. So our, emphasis from the first responder perspective is I'm showing up to a battery storage yard with 1,000 BESS units. Am I facing an incident in all of them simultaneously? And so this test is one that informs local AHJs and also puts local permitting authorities at a level of comfort, understanding that if that technology has been put through the rigorous destructive testing of a large-scale fire test, that we have at least the confidence of knowing we're going to be facing a single enclosure. That affects the duration of the incident. In Landis's case, that affects the dollar loss and claims that are coming in. So if I could see something that's coming through the industry as a trend moving forward, it's that a lot of these top tier manufacturers take the initiative to actually go through these large scale fire testing on their own. The difficulty is that if we don't have a standardized approach on is this going to be with ceramic heaters? Is it going to be with some sort of introduction of jet flames or torches to initiate these? Are the doors open? Are they closed? At day's end for us, we want to see the fire fully engaged and fully involved with that populated enclosure. We're measuring heat flux. They're measuring toxic compositions of gas and how much data that we get out of these large-scale fire tests is also going to influence emergency response plans. It's also going to influence our concentration reduction systems. How much CFM are we going to have to be evacuating and air cycles changed in order to keep the internal environment below a 25% lower explosive limit? For first responders, that's a critical point for us. So again, if we're looking at a lot of the battery cell and pack focused sectors of the industry, sometimes innovation in suppression isn't really the best approach. We're still, I've been through, in the 5 years that I was permitting these, as many religions that have come and gone, from direct water injection to liquid Novec direct inject, clean agents, which have fallen out of favor. So we're back to our basic concentration reduction systems: early detection, coordinated exhaust and ventilation, vetted through the large scale fire test and hazard mitigation analysis that tells us how we're going to have to control that internal environment in order to protect first responders and the local folks. So I realize that is a fast and furious download, but that is the perspective that we're looking at in permitting.
Yeah, thank you so much. I feel like your perspective is so unique to our audience, because a lot of us don't think about, like, who's going to go put that fire out? Is it safe to go inside? And I know we, in our discussion before this event, we were discussing a lot about, the standard tests that you can run on single enclosures and then propagation, but then there's also the whole concept of all of this fire suppression mechanisms that are there, and are they all working? This is something that I think we should all be aware of. So one of the reasons why I wanted to moderate this panel is to get kind of all the different representatives from this industry together and really shed light on what we should all know and understand, focus on for decreasing the number of incidents that are happening, help our industry become more efficient in designing systems and planning these projects. So Brian, your company has a similar goal. What is your goal with Soteria to enhance the battery safety community knowledge?
Yeah, so thank you first, everybody, for inviting me here, and I'm glad to be here. Soteria, really the heart of the company is battery safety, and while we put forward our own technology, we also know that we can't do everything. So we have our goal in terms of working with the industry is really to open up communication. That there's a lot of different perspectives about safety in the industry. Some people like to pretend that there's not an issue. Some people like to pretend that it's the only issue. And so we try to open up communication through holding events, through participating and supporting other events. So glad to be here. And in general, we try to do it like we're doing here, where it's sort of unscripted, meaning in an environment like this where you have a panel, you're going to get to the truth, versus a bunch of presentations where sometimes you get just a perspective that's been scripted, right, and approved. So opening up the communication. We also run training events for first responders. We invite first responders, especially those who are expert in lithium-ion battery fires, to speak to the industry. And so, from that perspective, our work is entirely around opening up communication, really not having it be our voice as much as it is getting other people's voices in a room and let people kind of hash things out, right? And I'll throw in one other thing, which is we believe safety is a system, that there's not a silver bullet out there. There's not one thing you can put out that's going to make the battery go from unsafe to safe. It's not a switch you can flip. And so the analogy is kind of seatbelt, shoulder harness, airbags, anti-lock brakes, crumple zones, bumpers, rear view cameras, radar. It's safer to drive today at 90 miles an hour than it used to be to drive at 20 miles an hour. And so I think the same thing's going to happen with battery safety, and I'll have more to say about that in a bit.
Awesome. Thank you so much. So what do you think has been holding the industry back from collaboration? Is it kind of just company IP? Can you tell us a little bit more about that?
So I think, and here's where I think it is related to communication. When you have a standard that becomes compliance, meaning you have to pass it, you have people who are going to have cost associated with that, who are going to jump on the committees and push that standard back, dumb it down. And you have people who have safety technology who are going to try to advance it, and insurance companies, thank you, are going to try to advance it. What the automotive industry's done very effectively for a decade is a safety rating system. We know it as the crash test rating, where they just crash cars in a bunch of different ways, and you get a rating from 0 to 5 stars. What people don't know is that system has evolved, and every few years they update the rating system, and so the industry has advanced in a kind of an incremental way, where there's not a compliance level, but there is a consumer input into it. And right now, the consumer has no input into safety rating, safety testing, safety compliance for batteries. And if we gave the consumer a voice where they could make a choice, okay, I'm going to buy this brand, which has a 5-star, instead of that brand, which has a 3-star, the natural competitive forces would help the industry advance. And that can be done at the cell level, at the pack level. So I think that's something that we have to work towards. That's bigger than Soteria, right? We're not going to do that. That's bigger than us. We're going to have to cooperate with a lot of different people to facilitate that, but we certainly want to be a part.
That's an excellent idea. I would also like to be a part of that. I feel like the projects that I've seen at Exponent, like a lot of them were like, oh, we wish we had more background from the end user on this device that failed. It could be very helpful in learning. I guess kind of similar, we're also trying, oh, Landis, did you have something that you wanted to add in?
So it seemed like the incentives are there for best manufacturers to build their products, right? So they were all trying to get staff, trying to build out products, and that's where the incentives were. And now they're circling back to safety. I mean, it was always kind of part of the equation, but they just didn't have time and staff, right? They're trying to build market share. They're trying to staff up their teams. There was many times where I'd go and look at a manufacturer's website, and they might have 4 products listed and then 5 projects. And then you go to their trade show booth at RE Plus, and they'll have 18 different configurations of something, right? And it's a lot of like R&D build out of their product on the front end, building out market share, getting chains with developers to buy their products, and then circling back to kind of this gamesmanship we're seeing now on the safety side of things.
Yeah,
That's interesting. You mentioned incentives. Oh yeah, Ben, for
I was
sure.
going to note, Landis, it's funny because that scaled exactly out of the cell. As you look, the U.S. has focused on trying to scale as fast as possible on cell, and yet it's cell and module, and yet our yields are abysmal at best, like abysmal compared to the worst producers as we look in Asia. It happened the same thing on the module and pack side, or on the large scale system side. As you see most of those, it's kind of funny. You look at the trends, even Volta's report and EPRI's report, and I know China isn't great at reporting their data, but if you look at other countries that are deploying too, I mean, the amount of deployments they've had compared to ours, the amount of events that we've had is substantially more. Again, back to trying to rush through, get something out there versus good practice, good scale, and good opportunity. It's seen from the cell all the way to the system level and into the field.
Yeah, do we think that like the multitude of the events that have been occurring, is this the main incentive to kind of improve our safety and or I guess for the companies to improve on safety rather than performance?
From a
Uh,
safety
Yeah, I would.
perspective, oh, sorry, go ahead,
Go ahead,
Ryan.
Mike.
Or Ben.
No, go ahead, Mike. Go ahead, Mike.
So I was part of the CEC roundtable that was kind of brought together after the Moss Landing incident. And, everybody I think California has the highest concentration of renewable energy and storage in the country. And then Kern County, I think, has the highest density of renewable and storage in the state. So what we're starting to see, and I think Landis and Ben both touched on this, that there were tax incentives and credits that were being offered for projects to meet very unreasonable deadlines. They were approaching AHJs with partial data submissions, incomplete testing, asking for permission to continue with construction and getting approval for that. We had to stand down the state legislature and stand our ground saying these were not safe for firefighters, and we needed to basically emphasize the fact that we were setting the standard for what we considered to be safe for our folks, for our public, for our first responders. And so I think what we're starting to see is now everybody's cycling back to this, or circling back to this reality that you can have these deployed, but if we rush through them, if they're pushing in jurisdictions that don't know any better and they're getting substandard installations, all this is doing is basically creating a black eye for the industry and optics that we're having to overcome with good manufacturers and good developers in jurisdictions that are referencing these anomaly events of old, battery technologies that predated NFPA 855, that didn't have things like large scale fire testing, that we didn't have real optics on effective deployment at either containerized versus in buildings. And so how are we dealing with the repercussions of that? And today's code is unfortunately written in the blood of yesterday's tragedy. It is reactive instead of proactive. And so we are chasing behind the technology that's already in place. Once the 2026 NFPA 855 edition comes out, it's already going to be chasing things that have changed since that adoption. And so how do we get ahead of that without having people take initiative on their own to emphasize safety? And if it isn't happening from the manufacturer and developer side, now we're getting California Energy Commission, California Public Utilities Commission that's coming out and saying, you will be doing these things. You will be setting these up. You will be providing emergency response plans early. You will be going through, the large scale fire testing, hazard mitigation analysis, failure modes and effects analysis. We need to know how these are going to perform on their worst day and really cite these appropriately.
It's funny. Mike, you mentioned that is, so I can't say for clients, but we've got about 11 investigations that are actually following behind the EPRI and the Volta report. Volta did a great job on battery energy storage system failures. EPRI has published the database. It's funny, if you look, there's a lot of data that didn't come through. Folks didn't submit it. So myself and a team of first responders who've been active in about 400 events that we've supported over the last 10 years are now behind the scenes been working with insurance, with OEMs, with investigators, federals, and others to actually go back and actually finalize what happened in those events. And in some cases, feed them back to the OEM or feed them back from a regulatory perspective. But you're right. All of that is now, luckily, most of those were not blood. It was a battery electrolyte that may or may not have been there, or batteries on the ground, but we're using those remnants to try to go and create what's next. That's really, really, really important and really critical. I'm glad that people are finally taking awareness, though. Again, back to it's getting better. It needs to get better faster. But folks are actually looking at that and taking keen awareness. And AHJs, even local, I'm in Indiana. We just are completing a project with what will be one of the largest data centers in the Midwest, and is going to be one of the largest battery, renewable wind, and solar projects, ironically tied to a coal asset for a huge data center here. two of us were pulled up to have that discussion as a multi-state because of who's involved to talk about what's going to happen. The AHJs were in the room and they knew what, and they actually were informed enough to ask the right questions. They brought what I'll say seasoned battery folks in, seasoned folks from each of those industries to actually talk. And rather than like forcing down the deployment, they forced the discussion, which is really important. So how do we move those discussions and public awareness? I'll end by saying that was the greatest thing, is they actually invited the public as well, because frankly, data center was frowned upon. And then battery and renewables here in the Midwest was frowned upon. It's not a discussion anyone wants to have. But by having an open room with knowledgeable folks, the community gained a great awareness, and there's actually tremendous backing. They actually saw a shift from about 90% were against it. And in the public, there was almost 100% were against it versus in the private sector. Now they've got greater than a 60% acceptance of where the current project scope is.
And I think an interesting point with that, Ben, is transparency. And there is a lot of hesitation within the industry for disclosing root cause analysis of failures.
Thank you.
And a lot of the concern, even at the state level, California Energy Commission and California Public Utilities Commission, what are we going to do with all the data that's being provided? All the testing and maintenance reports. I think everybody needs to adopt a perspective of cooperation and trying to get this moving from the position of concern as an industry to a little more acceptance. And the chair of the CEC had a great analogy. He said, we've been doing wind and solar in the state for decades, and they are now our children that are studying abroad with next to no issues. And our troublesome teenager is the battery energy storage industry, because we don't have the longitudinal data yet. There is still some concern about over disclosing, both from insurance punitive perspectives, limiting permitting options, and all of the different things that are concerning the manufacturers. But we need this transparency across the industry to really make significant pivots and progress in safety. Because if we don't know how they're failing, if we don't know the lessons learned, we're going to be stuck repeating the same problems over and over again.
Yeah, absolutely. So in terms of being more proactive and being more transparent, often a lot of times there are these large misconceptions about certain battery chemistries and battery types. Maybe Ben or Brian, if one of you want to chime in on maybe like one of the biggest misconceptions are in the industry.
Brian, you want to throw one and I'll throw one? There's probably several.
I think I'll throw out a couple. One is that there's a silver bullet, right? And there's not a silver bullet for safety. And people who propose one are they're misrepresenting that. And there's a lot of that. And I'll stop there, Ben. I'm sure you can add some others.
First one is for everybody, including the LFP providers. I'm amazed at how many of you still don't understand this. Lithium iron phosphate. There is not a battery chemistry. It's an electrochemical device that's actually mechanical. So called electrochemical mechanical device. They all have thermal events. There is not a safe battery chemistry today. Just the same as Brian with there's no silver bullet for a fire mitigation. There is not a battery chemistry, electrochemistry today that exists on the planet that is inherently safe, as in that it will not have some sort of a thermal event when put into rest.
Yeah, absolutely agreed. I want to throw in that at Exponent, like we've been giving talks on this at conferences, how not all LFP batteries are created equal. When costs of the material go down, then manufacturers start cutting costs around the cell engineering. And then this ultimately leads to an array of failure and failure responses. I do want to now direct a follow-up question to Landis, because he's ensuring the BESS projects that may or may not include LFP chemistries. So are these major ideas, like all LFP batteries are safer than other chemistries, shaping the way that you ensure your projects? And what would change if you're kind of made aware of, okay, now there's a spectrum of failure modes in these cells?
Yeah, so to Ben's point, we are aware that absolutely LFP can have thermal events. So we're not saying that it's foolproof by any stretch, but we do think it's the go-to default standard, right, in the industry right now. So if I had to look at that versus an NMC chemistry project, I think that the LFP is safer. I think it's less likely to break into a thermal event that involves from just a standard mechanical breakdown and regular use of it, but that also involves kind of external factors affecting it, right? So we ensure, Mike's based in Kern County, and he's right, there's an enormous amount of BESS installations down there, and I don't know what's going to happen when an earthquake shakes this. There's BESS being installed all over the place, places where there's high humidity, there can be flooding, there can be corrosion. So we do expect there to be some amount of thermal events at times, and so that's always something that we're expecting. What I would say is it kind of crowds out other technologies to an extent, right? So our ability to, there's enough of a market there for us to invest in personnel that understand that technology. To a lesser extent, we can understand NMC, but then it kind of becomes a difficult task for the insurance industry as a whole to kind of get into other newer technologies. So as new technologies come up, whether they're things like zinc or salt or different sorts of batteries, it's tough to get people in our segment to understand those sorts of things, understand the breakdown, understand the values, understand what can occur. And so it does a little bit crowd out some of the other technologies.
Well, thank you. So I think we have a little bit less than 10 minutes left to go. And I have been looking at the chat as the panel has been going on. And I think a little bit ago, a lot of folks were asking about the new Chinese standards. Does anyone have anything to add about that and what our opinions are so far on those?
Can I speak? Hello?
Oh, absolutely, go for it.
Hello, everybody. Nice to see you, Brian. Hello, Mike. There's a few people here that may know us and we may know them. Adam Black from Cycling Batteries here. We make the world's safest e-bike batteries. They also charge faster than every other e-bike battery. We are, this is just a pitch because there's what, 300 odd people here. Adam Black, Cycling Batteries. You can find me on LinkedIn. We are looking for a battery safety expert to work with us so that when anybody has any battery safety questions about our products, we've got somebody to point to. And their job is continually to look at all sorts of things that we can involve in our technology to make the battery safer. And if anybody is out there and has an expertise, particularly in this space, and we make small batteries for e-bikes, 48 and 36 volts, please write to me, connect with me. We're trying to find somebody who can specifically do that job and
awesome. Thank you so much for that. Yeah, going back to the panel there, many of us, you can reach out to folks at Exponent, folks at XC Technology, folks at Soteria. These are the top three, I would say. Thank you so much for that. But anyway, back to the panel. There's questions about the Chinese standards.
Yeah, Laura, I was going to say I'd put to kind of help put a pin in that, and would look for Mike and Brian and Landis to comment. China, frankly, again, greater deployment substantially. I mean, if you look at single company, most of those, look at a BYD or CATL, their deployments globally are greater than the total of any other company, all the other companies combined globally. So if you look at their quantities, follow their reports, it's massive. Whether that's their cell deployment or their deployment in the field, it's orders of magnitude. So if you follow their data stream, they, again, a lot of early deployment. They were some of the ones that between quantities and early information, had a lot of failures. Again, go back, check Volta reports, check EPRI reports. You have to do some pretty creative digging. I spent some time in China last year for about 2 months, helping dig into some data that was not public knowledge of far greater quantity of events that were out there that were from systems that were more than 2 to 3 years old. So they were, I'll call them the mature standards, if you will. And within those, I think even those companies recognized they weren't going to be able to deploy more. And Chinese Communist Party, you can hate communism all you want, But when you've got one dictatorship who's driving everything, they said, look, we own the battery world, we own battery deployment, we want to be the safest. They were very keen to go in and tell their regulators and everyone else, you're not deploying unless it's safer. I mean, they've done a great job along the way of cutting off chemistries. They cut off NMC for a while, and it was LFP only because they were having issues with NMC and NCA. They did the same thing with early battery systems. They did the same thing with vehicles. It started with truck and bus. They cut off deployments until regulation and stuff got up to speed. Obviously, we don't have the authority here in the US to say, or others to say, you can't deploy anything till our regulation catches up. They did that there, and that's what's happening in China. You look, their standards groups are saying, we're the largest deployers. We don't want our names on the data. They've actually done a really good job. If you look today, standards and deployment, along with tech, they are ahead of everyone else. They are one of the few that are actually out in front of all of their current technologies and are staying immersed in their emerging technologies. Frankly, I think some of that's because CCS or the CCP has a seat on every board. They probably get directly involved with industry because they're sitting on the board. They don't have a choice to not know something about what their technology is doing. That's harder here in the US. So long-winded, I would say that's important. It was in the chat too. It's critical, I say more than important, it's critical that our industry continues to involve with legislators, with our responders, with our community, and with our standards bodies. We have to be transparent enough so that we can get caught up.
Yeah, also we're not seeing any reliance on Chinese standards in the US market for utility scale BESS in the insurance market. Not yet. Maybe with time, but not right now.
We'll keep the CSA came out of China. That was done in China. So that one's leading. That was built by China, BYD being the first one to go through that. So a lot of input globally, but it came mainly out of China as part of their drive. So
This is very interesting. So we have just another minute left. I just want to open it up for 2 questions from the audience. So if anyone has a question for our panelists, you can go right ahead and chime in or raise your hand. I guess with the Zoom feature would be nice.
Well, if nobody else has got anything,
I've got a question.
Oh, go on.
Thanks, Adam. Sorry about that. Tina Singh, Toyota. I think it was Ben, you mentioned that there were more safety issues with batteries in the US than China. And I think you may have spoken to this a bit already, but any top like 3 or 4 reasons you think that is?
Top reasons for that. Yeah, ironically, what I will say, and for probably Mike has seen this as well, in most of those, it was not a bad sell. I think a lot of people assume that it was a bad sell. If you look, the top are majority of the key failure modes. And we've got, this is one that we just finished for a federal agency because they were comparing Chinese versus American deployments and basically quantity versus failures. So we have less deployed, but our failures have been higher. So we have a higher per deployment. Obviously, we don't have as many, so if we maybe that data would shake out. But improper cell chemistry selection, inadequate protection and safety systems understanding, incorrect or incomplete failure mode analysis, ineffective diagnostic methods and pre-diagnostic methods, which Mike hit on earlier, balancing and pre-charge flaws, their system isolation design, incorrect system operation modeling. So before they deployed it to the field, what it was supposed to do, knowing that from a modeling, their material suitability and compatibility, like balance of system of stuff they selected. Like we found in some cases, some of these failures were because of a $50 thermostat in an HVAC for a multi-million-dollar installation. Like they put a $50 Honeywell controller from Walmart, versus an HMI in there that would have been a more robust. And then a lack of sufficient design validation and testing. That was, a lot of our summary as we're going through investigations. That's what we're finding. The summary though is it's never been the chemistry. It's never been the cell per se that you selected. It's actually how you put it together and how you deployed it. That is back to our, Landis put it well, and so did Mike. We're rushing out with, frankly, what's a good brick, but we're building a terrible foundation or a house with it. It's crumbling and everybody wants to blame it on the brick. That's been bad for the battery industry, is folks believe batteries are unsafe. They're inherently safe. It's just how they've been deployed.
Yeah, and we have a saying, is the battery the victim or the villain? And in a lot of instances, we're seeing them being the low-hanging fruit, and they become the identified patient in the process. We've seen water intrusion from incorrectly installed water diversion. We've seen in Kern County, we witness tested every single device in every single box. So from an insurance perspective, that gives us liability protection. It also, whether the developer realizes it or not, it also helps them to vet and validate the fact that every single life safety device was tested and that we had correct addressing, coordination of the exhaust fans. And to Ben's point, we're seeing tiny bathroom fans put in these things, for lack of a better term, as their exhaust fans, exhausting combustible gas, not necessarily class 1, div 1 rated, and it's like, okay, is the fan going to cause an ignition of these exhausted combustible gases? Is it adequate for the amount of ventilation that we're looking for? And we saw consistent misinstallation, labeled devices, things that weren't correctly installed. As soon as they come, if they're integrated overseas and they come and hit US soil, especially California, they're instantly out of compliance because no C10 licensed contractor has taken responsibility for that particular design. So we had to do everything once they landed in our jurisdiction. Vet the integration of the water systems, do a leak test on all of the plumbing that they didn't want to list to UL or to NFPA 13 standards, heat detectors and gas detectors that weren't working correctly, gas detectors that were calibrated with gases that weren't going to be present, exhaust CFM outputs that didn't match the hazard mitigation analysis. So it's a very difficult process. And I think another question that you mentioned in the chat with us, Laura, is how do we have long-term sustainability of this relationship with the local HJs and potentially a 2.5-decade long project? And so testing and maintenance for us became a critical component to this. If we're going to the lengths of ensuring that this thing is operationally ready by kicking the tires and checking every single device, how are we assured that from year 1 to year 5 to year 10, we have that same level of operational readiness without requiring some sort of testing and maintenance? And some of the intervals that exist or don't exist for those is difficult because how often do you change the air filters? Well, we'll refer to manufacturer suggested intervals. Okay, did the manufacturer consider that we're going to be in 110-degree weather in the middle of a desert in California, blowing 40 miles an hour, dusty, silty conditions every day? Unlikely. You know what I mean? So these are things that we're looking at as hurdles to overcome moving forward. And even from an insurance perspective, we have operational permits that we issue every year for these battery storage projects in Kern County. And as part of that, we require updates on contacts, emergency contacts, as well as providing all our testing and maintenance reports. We want to see that they're doing this as a condition of their operational permit for the following year.
Okay, so with that, thank you all. We're unfortunately over time. I know I promised additional question, but thank you all very much for this wonderful discussion. And clearly we have still a lot to discuss. But yeah, this has been very great. Everyone give a round of applause to our wonderful panelists.